it should be okay.
Okay.
Good morning, everybody. My name is Claudio Savaglio. I am a researcher at the National Research Council of Italy, and the paper I'm going to present you is entitled Cloud and Edge-based ERP Systems for Industrial Internet of Things and Smart Factory. My co-authors are Dr. Prakasha, Dr. Garg, Dr. Bawa, and Dr. Spezzano. This is an outline of the outline of the presentation, a very brief introduction on enterprise resource planning systems, which is the research domain of our paper, a rapid background on cloud and edge computing paradigms, and hence a review about the application of ERP systems within industrial Internet of Things and smart factory, and in particular emphasizing the current state of cloud and edge-based solution for ERP. Finally, a discussion and, as usual, conclusions and future research directions. So what an ERP, enterprise resource planning system, is? ERP are a well-organized collection of softwares whose goal is timely integrating business processing with the final goal of supporting the management of effective cross-functional operations within an organization. In other words, ERP are software packages that enable company to integrating their data through the entire organization, and in such a way, ERP allow providing the correct input to the management layer, so supporting management action, coordinating the company resources, and also promote standardized best practice and action aimed at the cost reducing. Is widely recognized that probably ERP systems is the most important innovation in the corporate use of informatic technology in the 90s, and it's the reason why companies that deal with ERP make a lot of money, and they are very big company like Oracle, SAP, and so on and so forth. But how a conventional ERP system actually work? Basically, you can imagine an ERP system as a very big single database that works as a central location for the storage, distribution, and forwarding of the data between the various departments and business processes. So you can imagine an ERP like a very big monolith database that works among financial district, human resources district, purchase district, and so on and so forth. Obviously, the management of such a complex sharded and monolith system is very costly and challenging. So over the years, several solutions have been developed with the aim of avoiding such a centralized approach to the data and resource storage. In particular, recently, cloud and edge computing paradigms have been used and exploited to implement ERP systems. What is cloud computing? Cloud computing, as most of you know, cloud computing is a recent, nowadays it's 20 years old, 20 years old computing paradigm that is based on network, and the idea is to provide hardware, software, and the networking service to the clients through internet. In such a way, user can benefit of always on, anywhere and anytime and any place services, regardless the complexity and the implementation detail or the underlying infrastructure in such a way user pay for what they use. They can elastically scale up their infrastructure, and in such a way they can, let's say, improve the agility of their business and shorten the time to market. Edge computing goes in the opposite directions of cloud computing, because edge computing is an emerging paradigm that is based on the concept of proximity, while computing was based on the network and hence on remote resources. Edge computing is a proximity-based computing paradigm according to which data should be locally treated as much closer as possible to the point, to the location in which they are generated. In particular, these data are treated by the edge servers, also known as edge platform, and due to the proximity, edge server can perform context-aware and lightweight tasks on the raw data. And if needed, they can offload to the cloud or to the enterprise data center a reduced amount of data, or the main findings, the refined model, and so on and so forth. Thanks to its features, the edge computing allow obviously reducing the data communication, the privacy and the security risk, and as a result, the bandwidth and the energy consumption. So it has very nice features, especially for the novel application area. Just from this quick overview on ERP systems, cloud and edge computing, two main considerations emerge. The first one is that ERP systems are very useful in any organization, in any domain, but specifically and especially in the complex and cyber-physical domains such as industrial IoT and smart factory, because ERP can deeply and positively affect the core business by supporting processes related to the monitoring of the production chain, the identification of critical issues within the workshop, and as a result, they can contribute, ERP can contribute to downtime prevention and the workload balancing in smart factory. As a second consideration, main benefits of cloud and edge computing perfectly match with the needs of ERP systems and with the goals of smart factory. Indeed, if we couple cloud and edge computing with ERP system, we can enable the processing and the storage of large amount of data. We can enable the continuous and real-time information sharing between customer and consumers. And as a result, we can respond to the consumer behavior and the organization needs in a rapid and agile way. Hence, it can be stated that the exploitation of cloud and edge computing within an ERP would support the creation of an even more smart factory, which could be more context sensitive and more reactive. So the exploitation of the decentralized communication can be of great importance for the smart factory. On the basis of these considerations, the two paradigms of cloud-based ERP and edge-based ERP recently gain attention. What is cloud-based ERP? Basically, cloud-based ERP offers the same solution and the same functionality of ERP, but by leveraging on cloud. So ERP ERP system can be provided according to infrastructure as a service, platform as a service, on service as a service model, cloud model. Okay, and obviously the benefits for the companies are great, because they don't have to invest a lot of money in IT infrastructure or in maintenance cost. According to Fauchette, and it is also to other, according to other, let's say, researcher, cloud-based ERP can provide new business value and can provide a competitive advantage to the company. In particular, Al-Mashari found that the mainly adopted cloud-based ERP models are the infrastructure as a service and the software as a service model. And the driving factor lie in the size of the business and in the requirements, in the privacy and security requirements that any organization has. Regardless of the specific model, infrastructure, platform, or software, the main pillars that are well established for cloud-based edge compute, for cloud-based ERP, are virtualization, agility, on-demand, and pay-as-you-go. But anyway, CRP is still in its infancy, and nowadays there is no agreement on an exact definition for CRP. Edge-based ERP is an even more recent field of research, and the idea here is to couple edge computing benefits with the distributed infrastructure, and so as to provide ERP in a more cheap way by offloading part of the effort from the core of the cloud ERP and forwarding the most computational intensive task on the cloud. Obviously, there are benefits on security and privacy preserving, and edge-based ERP enable faster decision making. In particular, an interesting finding is that ERP is better suited to small-sized business with the sensitive data to protect. And as another finding is that even more than cloud-based ERP, edge-based ERP has the potential to provide small-sized organization with a substantial competitive advantage. So edge-based is even more suitable for small-sized companies. In particular, an interesting research area is the exploitation of ERP module on the exploitation of some of ERP module on the edge and some other on the cloud. And this is the so-called hybrid cloud edge ERP. So, summarizing, by analyzing the limited literature currently available, it emerges that the advantages of C and E ERP for IoT and smart factory are the cost savings, the enabling of new business model, the improved agility and flexibility, and the higher productivity and efficiency that they can provide. On the contrary, there are some disadvantages. For example, organization issues and conservative mindset are a very big obstacle, because obviously it's very hard to re-engineer processes or to ensure the business continuity if the paradigm of the factory is changed, as well as few companies want to storage their data in external locations. There are some infrastructural needs. For example, traditional on-premise ERP system consists of specialized hardware and proprietary software that work on over local area network. So this change is also has a big impact. And finally, most of companies have concerns about the vendor lock-in and interoperability because they don't want to be dependent on a single cloud provider, or they don't want to have only partial access to their resources. This table gathers the previous considerations and highlights that the same benefit is provided in varying degree according to the cloud and edge-based implementation. To conclude, we have seen that ERP system focuses on the integration of system and services, automation of business process, and secure sharing of data to the entire organization. Due to these features, the ERP competitive advantage is further increased by coupled with new technologies like the industrial Internet of Things, because in this way we can match the constant need for change in the organization operation. And we have introduced the cloud and edge-based ERP. As for every technology, also the adoption of C and E ERP implies both pros and cons that should be carefully analyzed. From a technical perspective, these two paradigms are both very promising enabling technologies, but obviously there are some obstacles like the conservative mindset and the availability of internal technical knowledge or resources. So this is a very big obstacle to the adoption of C and ERP adoption. But anyway, organizational characteristics and industry sides are two key factors for the adoption of cloud and edge-based ERP. As future work, it will be very interesting to study the novel hybrid cloud edge reference architecture to support ERP system, so that to overcome the limitation in the current ERP and ERP system and fully exploit the other Internet of Things potentials. Thank you for your attention.